Lesson 20, I can solve problems by analyzing different unit rates given in words, tables, equations, and graphs. So we're continuing on with our lesson with the idea from lesson 19, where we will be using those graphs, using those tables, the ratio tables, the equations, in order to look at different unit rates. So we did this already on Friday. We're just going to be doing some more complex problems today. Let's get started. Okay, let's skip down to the exploratory challenge. Mallory is on a budget and wants to determine which cereal is a better buy. A 10-ounce box of cereal costs $2.79. And a 13-ounce box of the same cereal costs $3.99. Which box of cereal should Mallory buy? So what we need to do here is find the unit rate of both. So I'm going to take $2.79 and I'm going to divide that by 10. Let's use this space over here. So in 5th grade, we learned about dividing by 10. You can just move the decimal place over one spot when you're dividing by 10. So it's 279, what is that, thousandths? But when we're talking about money, we need to round up to the nearest hundredths place. So since this is 5 or more, I'm going to round up. So it's about 28 cents per ounce for the 10-ounce box. The 13-ounce box, so $3.99. This one we actually do have to do the division, divide it by 13 to figure out how much money per ounce. So 13 doesn't go into 3, but it does go into 39, exactly 3 times actually. So minus 39 is 0, 9. 13 does not go into 9, so 0. But I could bring down, oops, it doesn't really look like 0. Bring down another 0. 13 goes into 90. Let's try times 6. 13 times 6. 3 times 6 is 18. 1 times 6 is 6. And 1 is 7. 78. And it's just barely not going to go. We can't get another 13 out of that. So, yeah, 78. And then that's 6 times. When I do my subtraction, 10, 8, so 12. And I'm actually going to stop there because I already have gone 3 decimal places. And I'm going to do the same thing where I round to the nearest hundredths place because it's money. So this one is about 5 or more. Makes this round up. So about 31 cents per ounce. Put a 0 there like I did in the last one. So now if I'm comparing which box of cereal should she buy, between the 31 cents per ounce or the 28 cents per ounce, this one is cheaper, which is the 10-ounce box. So the 10-ounce box is cheaper. What's the difference between the 2 unit prices? So from 28 cents to 31 cents, that's 3 cents more. So the 13-ounce box is 3 cents more per ounce. Part B says Vivian wants to buy some watermelon. Kingston's Market has 10-pound watermelon for $3.90 for 10 pounds. But the farmer's market has 12-pound watermelons for $4.44 for 12 pounds. Which market has the best price for watermelon? So let's start with this one because we can divide by 10 really quickly, just like we did in the last example. I could just move the decimal place over 1, which is now 39 cents per pound for this one. Here we actually do have to do the division. So 444 divided by 12. 12 goes into 44. 12 times 3 is 36. 12 goes into 84. Well, I know 2 times 7 is 14, so let's try 7. 1 times 7 is 7, 8. Yeah, so 7 times. And it comes out even. So this one is 37 cents a pound for the unit rate. Which market has the best price? So that would be the farmer's market with the 12-pound watermelon. What's the difference between the 2 unit prices? 37 cents to 39 cents. So 2 cents. 2 cents per pound. Let's put LB for pound. 2 cents per pound. Okay, number 3 is just like it. So it says Mitch needs to purchase soft drinks for a staff party. He is trying to figure out if it's cheaper to buy the 12-pack of soda or the 20-pack of soda. The 12-pack of soda costs $3.99 and the 20-pack of soda costs $5.48. Which pack should Mitch choose? So we're going to find the unit rate. So we've got a 12-pack for $3.99. So $3.99 divided by 12 to figure out the cost per soda. Okay, 12 doesn't go into 3. 12 goes into 39 3 times. Minus 36 equals 3. Bring down the 9. Same thing again. Minus 36 equals, I'm kind of running out of room. 12 goes into 30 2 times. Minus 24 equals 6. And 12 goes into 65 times. I don't actually need to go that far because we're talking about money. So I only round to the nearest hundredths place. This is less than 5, so I do not round up. So it's about 33 cents per soda. And then the 20 pack, 548 divided by 20. 20 doesn't go into 5, but 20 goes into 54 2 times. Minus 40 equals 14. Bring down the 8. 20 goes into 148 7 times. 148 and 4 times. That comes out. So again, less than 5, so I don't need to round up. Just about 27 cents per soda for the 20 pack. Oops, sorry guys, you couldn't see that. So which pack should Mitch choose? So we're comparing, here's the 20 pack, 27 cents, the 12 pack, 33 cents. So the 20 pack is going to be the more affordable option. So Mitch should choose the 20 pack of soda. What's the difference between the cost of 1 can of soda between the 2 packs? From 27 cents to 33 cents, that is 6 cents per soda. Okay guys, and the next one is the exact same idea but with batteries. So for kind of a checkpoint in our lesson, I'd like you to pause the video and go ahead and solve number 4 on your own. Press play when you're finished solving parts A and B, and we'll check your answers. So go ahead and do that now. Okay, here's the answers to number 4. So for the 20 pack, it would be 62 cents per battery. For the 12 pack, it would be 60 cents per battery with a difference of 2 cents per battery. How did you do? Okay, for number 5, the table below shows the amount of calories Mike burns as he runs. So number of miles ran. When he's ran 3 miles, he has burned 360 calories. And the ratio table continues. Fill in the missing part of the table. So in order to do this, we need to know the unit rate. We need to know what do I need to do to this number to get this number. That way I can figure out how much calories he burns per mile. So what we can do is we can divide 360 divided by 3. 6, 3 goes into 6 2 times. So 0. So he burns 120 calories per, it's a little bit blurry. Let me see if I can fix this here for you guys. There we go. 120 calories per mile. So all these numbers, we would be multiplying the number of miles ran times 120 to get the calories burned. So now if he has run 9 miles, we're just doing 120 times 9. So 0 times 9 is 0, 2 times 9 is 18, 1 times 9 is 9, and 1 more is 10. So 1,080 calories for 9 miles. And just, it's always a good idea to look and see, is this a reasonable answer? Does it make sense? Yes, it's between 720 and 1,440. Now, if this number would have been, for example, larger than the number of calories burned in 12 miles, I would know that is not a reasonable answer, and I would go back and check my math. Okay, number 6, this is really connecting to that content goal, using a ratio table, using a graph to compare 2 unit rates. So Emilio wants to buy a new motorcycle. He wants to compare the gas efficiency for each motorcycle before he makes a purchase. The dealerships presented the data below. So for the sports motorcycle, we're looking at this ratio table. And for the leisure motorcycle, we're looking at this graph. I see that they both have 10 gallons as a part of their data here, and we know how to easily divide by 10. So that's a really quick way to find the unit rate. In other words, how many miles per just 1 gallon of gas. So 575 divided by 10 would give me the unit rate. And I know that if I'm dividing by 10, I'm kind of just moving a decimal place over. So this would be 57.5 for just, 1 gallon of gas. 57.5 miles per gallon. Over here, if we're going 10 gallons, that would be 550 miles. So 550 divided by 10, I would just be moving my, imaginary decimal place over 1. So it would be 55.0 or 55 miles per gallon. So which motorcycle is more gas efficient? Gas efficient means more miles per gallon. So when you're looking at cost efficient, you want, the lower price, but gas efficient, you want your motorcycle to travel more miles per just 1 gallon. So we're actually looking for the one with the larger number, which is going to be the sports motorcycle. That's a larger miles per gallon, 57.5 miles traveled for just 1 gallon. Whereas the leisure motorcycle is just 55 miles traveled on 1 gallon. So, which motorcycle? We would say the sports motorcycle is more efficient, more gas efficient, I should say, by, and it says how much, so we want to say the difference. So like 57.5 minus 55.0 to know the difference. 5 minus 0 is 5. 7 minus 5 is 2. So 2.5 miles per gallon.